Okay. Okay. Our final presenter is Kyu-ye. Please welcome her.
Ladies and gentlemen, finally, yeah, I'm waiting for a long time because I'm final presenter. So, yeah, I think everyone maybe like starving, but yeah, I have to presentation for 20 minutes, so please be patient. Yeah, my name is Kyu-ye Sung, go by Richard, and my mentor is MLJejuCamp. So the topic is the generating affective text using relational GAN. Actually, it's relation network, but I made name in this week. So relation GAN is REGAN. So actually, this topic is my life project because it's related to my vision. So I will explain about it soon. So I will introduce myself in shortly. I studied life science and computer engineering in bachelor's course. After that, I studied human-computer interaction, especially in brain engineering. So, based on this background, I'm interested in technology related to human behavior and human cognition. So, I love to study machine learning and emotion analysis simultaneously, and also I worked as a US researcher and growth hackers. Do you know the growth hacker? Actually, this is a little new word, but it's not famous. So data-driven marketing. So months ago, I worked at this position. So yeah, so I choose the topic because that's my background, and also my mentor is Jacob Lee. He's a famous YouTube celebrity. He teaches deep learning in Korean. So he has many lectures in online, free of charge. So yeah, he is very famous. So I introduced the whole process of my presentation. First is introduction, and second is progress, and last one is further approach. So, yeah. Actually, I think the 1 month is very short. So, the first week, I'm searching the data set and setting a cloud ML engine. I think it's very hard to me. And second week, building pipeline and little tests. But building pipeline had many problems, so many errors. So, finally, third week, I can train my model finally that week. So it's very short time to run my model. So yeah. So last week I wrap up and just preparing the presentation. So I get us some simple question. So let's start with this. For example, 1 and 1 is 1, 3 and 4 is 0, 7 and 2 is 0, and 4 and 4 is 1, 6 and 3 is 0. So 3 and 7 is what the answer is? 0? 0 and 1? This is IQ test. Who is smart one? Actually, yeah. The answer is 1. Yes, because O meaning of operation O meaning is just plus, and the answer is the summation of this operation. So 101 is 2, but 2 is an even number, and so even number meaning is 1. Yeah, odd number is 0. So 3 plus 7 is 10, is an even number, so it's 1. It's just simple, not simple. Yeah, sorry. Okay, so yeah. And so this case is related to relational reasoning. It's my main topic. If I put x and y into relational networks, the output is 1 or 0. Previous page based on previous page. So relation networks analyze the x and y relations, and output is we can get output 1 or 0. So this content is published by DeepMind in this year, maybe lately. So relational reasoning is learning to understand the stand between the different objects or ideas. So I think this is considered very important and essential characteristic of intelligence. So I choose this topic because I think this can be this relation network is proposed to solve the problem like hinging on inherently relational concepts. So I choose this relation network. So also it can be explained to this composite function. It's simple function. So object I and object J is just object, and pair set is they are enter into the function G, and function G output of function G and sum them up, and after that it just pass through enter the function F. So function F and G is the function of F and G is analyze the relations between the object I and J. So why I choose this relation network? I bring some example of BA/BI task published by Facebook AI team. This is the 2 sentence and 1 question. So 1 question is related to 2 sentences. So let's see it. The first one is Mary moved to the bathroom, and second, John went to the hallway. Question: where is Mary? So the answer is very simple, but its inference process is like here. Firstly, Mary moved to the bathroom is related to the question where moved to and bathroom is related to the where, and the Mary is related to the question main subject of question. So we can infer that where is bathroom and Mary? Yeah, Mary is bathroom now. So it is a high relative score example. But second sentence and question. So where is related to went to and hallway in second sentence, but it's not same with subject between the question and second sentence. So it's John and Mary is not, it's different person, so it's low relative score. So you can infer the answer is bathroom. So this is a human cognition and inference process. So I think relation networks can analyze all kinds of relations between the target pairs. Yeah, many kinds of target pairs. So I choose the relation network. So I will talk about REGAN in detail. This is a Socrates quote. It's very famous. So to know thyself is the beginning of wisdom. I love this quote because I think it's the best important thing in the society problem, because I think that self-knowledge is the best key to solve the problem in our world and society. So this is a message between the machine and human. So machine said, I'm depressed, like emotional text, but human replied that, oh, do you have any problems like this? So if I assume that human is me, I can talk with myself, because I will I will train the machine using my words and sentence and my talk message. So it can be this machine helps know self-knowledge clearly. So this machine is what I want to make. So the expected output is shown in this slide. It's trained a targeted emotion REGAN is generating targeted emotion text. So for example, negative REGAN is generating a negative sentence like, I'm depressed and I feel pretty bad right now. Why are you so rude like this? So it's a very interesting and some like human. So so I will make this kinds of output. My contribution is actually previous text GAN can analyze only sequence similarity between real and data, but actually many text GAN research exist, but almost paper is using LSTM but our REGAN is analyzed relation between the real and data set, so we can get some more specific and human-like results in generating text field. So related works, I bring two examples. The first one is text generation using generative GAN, generative adversary training. So first one is positive sentence generating sentence, and second is negative generating sentence. So you can read it, but we cannot understand clearly. So best and top notes, Newton, mom, and goodbye, more like this. So we can understand it. So also negative one, and second one is generating examples of GAN. So generator is RNN and discriminator is GRU. So a generate sentence, keywords, nostrils, titles, be able to titles, restoring his. So I think it's a little weird meaning. So many related works and generating text is not a good performance in this field. So I think the relation networks can solve this problem. So I will talk about my data sets as Twitter content. I use the Twitter content because some people publish this data set in online really. So and I use this. Also, I think that Twitter can reflect emotions clearly, so I choose it. But there are some cons of this data set because, as you know, the Twitter set has many internet language and incorrect grammar text, so I'm a little worried about it. So the number of the data set is 40,000, and also there are two parts in this data set. First one is a content, a second one is emotion label. Emotion label is made by experts in psychology field. So each content has emotion label. So we can understand this what the emotion is for each sentence. So I will use these two contents, but in this raw data set, there are 13 emotions in there, but 13 emotions, the number of 13 emotions are unbalanced, the data unbalanced, so I have to change it 3 centimeters more simply. So 13 emotions to 3 centimeters, like positive, negative, and neutral, based on the circumflex model. circumference model is a famous emotion model. So I used it. So yeah, it's grouped by 3, negative and positive neutral. Okay, so I will talk about REGAN model in detail more and more. First, real data and generated data, that is fake data, enter into discriminator, and discriminator, and then discriminator is our relation network, and generator is using LSTM. So relation network requires 2 inputs. So 2 inputs enter this RN, and then output of this relation network is real data logit and fake data logit, and their value is calculated by sustained distance loss, sustained distance, and it makes loss. And then, but there have a problem because in relation network require a label because relation network analyze the relations between the objects. So I have to add the label like supervised learning. So I attach the additional output layer to train the relations. So in this case, the criteria is grammar. So real data, discriminator outputs of real data is correct grammar, value 1, and fake data's output is 0, incorrect grammar. So we can get real cross entropy and fake cross entropy. So finally, previous sustained distance loss plus and cross entropy loss, sum them up, and then we can get discriminator loss. So this is the hyperparameters and my settings value. So data set is it's a 40,000 and positive, negative, neutral, and then short emotion sentence. I also use maybe experiment 3. So I will explain it soon, and then. Model parameters I cite it by a paper, like simple neural network, simple reasoning relation network paper. So there are 3 G functions hidden layers, 4 G functional hidden layers, and 3 function hidden layer. And besides the 32 GPU8, but GPU8 running time is average 10 hours. So in Cloud ML, so mentor and I spend a lot of credit, maybe $2,000. So mentor so already over credit and charge in his card. So we are very embarrassed. So yeah, April is 10. So round 1, training text with 3 emotion label. This is the first model. There are many problems in model. I use 3 emotion labels to train the real data, and it's like a semi-supervised learning. And then the function is Rn. A function of Rn is classify of each word, especially emotion words, and then RN helps generators to update. So this is the first result. You can read it. Can you read it? Chad, tree, roasty, afternoon, not. So yeah, I think it's very weird and very not good results. So I'm so surprised. So I found that what the problem is. First one is data cleansing problem. Yeah, so many tags in this first result, and then hyperlink, and some special characters without meaning, and also mixed emotion text like terrible and happy. Which emotion? Yeah. So, and also I found that RN function is not working well in this model because output target is wrong. Yeah, wrong. So grammar and emotion is confused how to follow the emotion. So I think it's very first model in my project. So I have to solve the problem. So data cleansing, and also emotion targeting problem, like output targeting problem is very big problem. So I will use one targeted emotion as a real data to remove the confusing which follow emotion, and also I solve the incorrect grammar is to solve. I made so label real data is one is correct grammar, and fake data is 0 incorrect grammar. So let's go second experiment. So round 2, training task using targeted emotion data. So this is a final model, but yeah, also it has my problem. But actually, I have to test our train for total 6 class, 3 emotions and 2 level of grammar. But actually, I cannot apply the info GAN or categorical analysis. So I just apply a binary label. So I already said about it, grammar and incorrect grammar and correct grammar. So, and I put into the only one target emotion as a real data to solve the emotion confusing following problem. So this is the result. Hey, I'm positive REGAN. So yeah, chef's place, home, dates something, dad, nothing but it, stands race didn't see. So it's also weird. So I think that it's not good enough. It's not good performance, of course. But I think I felt that this phrases feel like positive because some words are positive and few words are negative, and then it's I think a little interesting. I think it's a little interesting. So I to verify the emotion of this phrase, I used the Microsoft Azure service. The service give the result of sentiment. So I put into my generated sentence into that service. So I got the result of that is a negative. So left side is negative and right side is positive. So 14% is a negative meaning. So I think it's negative. So, but it's a positive REGAN, but it's negative. So I have a little disappointment. But negative REGAN, negative result is 1%. So I think it's a little difference from the between positive and negative results. So I think a little possible. I can find a little possibility, and then and also I searched that cosine distance between words. So like example, chops is 0.79. So it's very far distance. So I think it's the training performance is not good. So I can find the problem also. So also I try to put into the nature data as a real data. So this is a result of generating text in nature. Pale leaves all download turn dress very last day's nails. So it's more chaos, but I think it's a little nature, but yeah, it meaning to verify this 2% negative, so it's a very negative sentence. So I think I have two issues. Actually, many issues, but I grouped by two issues. First issue is proper grammar doesn't reflect generated sentence. It also, previous version has a same problem, but I think suspect causes two. One is training model isn't working well, and second, too many various real data set to train in RN. So RN is confused. So I think the first one is I have to redesign in loss function and all of my model change it. So I think it's have no time to test in 1 month. So I choose the second cause, suspected cause. So in case of second cause, if I put one target emotional data, only one, not whole data, into RN as a real data respectively, RN will work well, I think. So I will do experiment two and two. Actually, it's around 3. So I will talk about it soon. And second issue is each generated sentences reflects negative emotion. Many whole result is reflect negative emotion. So I think if I put one target emotion data into RN as a real data, the generated sentence is not similar to real data, but it can reflect relations only or emotion of real data. So round 3, training task using one emotion data. So I put the negative only one data into RN. So the data set, the one data set is here, a very positive sentence. Red font is, do you know the meaning? So I think Hussein knows about it. Hussein knows about it. It's a Marlboro advertisement. Men always mean below because of romance only. So I cite this sentence. So after I trained, I got the some generic sentence. Further heart in the essays, love, kind, nickel, only breast, rich, heart, go, so child. Yeah, I think the love and like hearts meaning is like positive, but Microsoft Azure, so it's a negative. I think it's not good for us in Microsoft, but yeah, a negative also generic sentence, but like pain bag and it's like little bad words in here. But so it's results of 1% is very negative sentence. So I have one issue. So RN is working in analysis of relations between real and fake. I think RN is working well, but it's not good enough to train based on tuning. So I have to more tune about my hyperparameter model. And then second issue is grammar, still problem. And I have to work in further works. So training model isn't working well, I think. So I have to redesign the model whole. So experiment 1 and 2, the RN function of RN is different. So first one is analyze only real data relations. Second one is analyze all data relations. So reflecting emotion tends to show negative bias. So I think that two embedding problem and in psychology research, almost basic emotion reflect negative some degree. So And second, reflecting proper grammar is working well. I have to change my model, and performance isn't good. I think max length, so long length must be reduced and modify and improve my model. So conclusions, and RN is bigger than you think. So I had a problem in training and long hours, and also reflecting to use. I want to try to use InfoGAN or GAN instead of assisting GAN, but I cannot. I have no time to apply this, so I will apply it in the future. Yeah, and I also did to validate RN only. Actually, my data set is so big, so I cannot test the RN only in my local environment. So it's troubleshooting and time-consuming. And memory overflow, I solved this problem based on changing my model. And this is my GitHub and update. So if you like to know it more and more, just read it. I write many explain of my project in detail in README. So this is my picture. And also I went meeting with Chanu. Chanu is special mentor because they in a month like participant. So it's my picture, and thank you for attention. Thank you for our guys, and thank you MLJejuCamp. Yeah, thank you.
All right. Let's get one or two comments on our questions.
Okay, so have you thought about adding a simple trigram model and with one of reference that would fix a lot of mistakes in the output or improve the grammar?
It's like
like a traditional
model. But I haven't tried it. But it's improve grammar. It can help improve grammar.
Yeah.
Yeah, actually, I wanted to solve the grammar problem using only using relation network. So I didn't apply anything but only relation network. So I think, but relation network is not working well. But I guess the many problem in my model not relation network is not the cause is not relation network, so I will apply of your suggestion later, but maybe based on relation network. Yeah.
Okay.
Yeah. Thank you. Suggestion.
In my opinion, there is a bad grammar in your generation because structure of the sentences, where a sentence is a sequence of many words, like probably even 10, at least 5, but you basically, your discriminator, which should judge the quality of the sentence, you reduce its judging ability, because relational network is, you have a bottleneck G function, which is a function of only 2 objects. Basically, when you are using only a bottleneck as a function, which is only 2 objects, there is a very high chance that you use all the structure, which is like compounding of many words. That's why, probably to make a structure better, you should, another architecture which incorporate many words, not only 2 as relational network. And second thing is also, I think position encoding or position embedding is very important, but I didn't hear whether you used it. Did you?
Just word to back. And,
oh, yeah. So in original paper, they actually included positional embedding or encoding. So you have a sentence, each word is in some position, and basically they concatenate this information to word embedding as well. So, but when you do summation of all G functions, basically you use temporal information where words have been. And one way to hack it is add positional embedding. So, and positions, of course, is very important for structure. Otherwise, it's just a bag of words, because you are doing summation, which was temporal information. And third comment is, so yeah, training GAN on text, which is discrete. That means it's not differentiable. And many, and many people is currently training GAN on text, and I wonder how you train it, because generating text is generating something discrete, and how you differentiate that part. Yeah, it's a question. What did you use?
I used the discriminator as a like a GAN 1 or 0 and discrete binary number.
Okay, I think you guys can take it offline.